Hi, everybody. My name is Michael Zornick, and this is a talk that I recently did at the Philadelphia Elixir meetup. The title is Working with Time Zones Inside of a Phoenix app. Before we get started, just a little bit of information about myself. As I said, my name is Mike. I am a developer and teacher from Philadelphia, Pennsylvania. I work for myself. I do a mix of contracting and other projects. I've been using Elixir for about 3 years and really like it. And today we're going to be talking about time zones. So specifically, we're going to be talking about what time zones are, how Elixir handles them, and then some strategies about how you can apply working with them inside the context of a Phoenix app backed by an Ecto database. So before we get started, I want to do a quick review of some terminology so we can kind of be all on the same page about time zones. The first thing to understand is that time, as we will discuss it, is a system of measurement that was invented by humans. It is extremely fallible and will make your life as a programmer extremely difficult. So the way I'm going to kind of talk through time here is through a series of layers. And the first layer here at the bottom is what we would call atomic time. So atomic time is actually a measurement of seconds. It's the definition of what a second is. And many atomic clocks are based off Acasium decay. I believe some of the more advanced ones are based off of microwaves and some other physics, but that is clearly outside the scope of this talk. The key takeaway here is that when we talk about atomic time, it is the description of seconds and how many seconds have passed. Now, here is an example of an atomic clock. This one is from Boulder, Colorado, as considered one of the more accurate ones. And yeah, so you can see it's a lot of fun. On top of atomic time, we have what we would call universal coordinated time, or UTC. This is basically made up of atomic time plus this concept of leap seconds. And the reason leap seconds come into play is that even though we have defined what a second is, and we say, there are so many minutes in a second, and hours in minutes and hours and days, the rotation of the Earth is actually not as precise as you might think. And so from time to time, if we want our understanding of time to kind of match up with how the Earth works, we need to trim or add some seconds. And so those are called leap seconds. And through leap seconds and atomic time, we can figure out what universal time is. Universal coordinated time, specifically. Now, when talking about UTC, you will also hear the term GMT, or Greenwich Mean Time. Now, generally speaking, in common conversation, these can kind of be thought of as the same, but if we're really getting into the terminology of things, you should understand that UTC is a time standard, and GMT is a time zone. So just kind of keep that in mind. The next layer of wall time here is our concept called standard time. And the idea of standard time is, we have the Earth, and it's rotating around the sun, and it's spinning. And so if I stand on one part of the planet and somebody stands on another part of the planet, we're experiencing, sunrise and high noon and sunset at different times. And so the idea of standard time is basically to define a section of the map or the globe or where you're standing and say that this is the definition of, this is the definition of like kind of high noon and sunset and sunrise. And that has gotten through basically taking UTC and applying a time zone offset. So if I am standing in New York, I am in Eastern time. And so there's going to be this offset from UTC or GMT to say what time I'm in. And that will be considered our standard time. Now, we're not done yet, because on top of standard time, there is a concept of wall time. And this is what it actually would actually say on the wall or on your wrist if you're to look at the clock. And this is changed or just, devised through standard time. So basically, standard time can have what we would call a standard offset, which is basically daylight savings time. So daylight savings time has a whole history. You can find some cool videos on YouTube about it. But it does make our lives as programmers very difficult because daylight savings time, the rules are different. So each country kind of defines their own rules. And even in the United States, we have different states which have different augmentations of the rules. So as an example here in Arizona, if you're driving through Arizona, you may leave and enter a different time zone as much as like 5 or 6 times, which is really, really confusing. Now, things do change, unfortunately. Celestial mechanics and the rotation of the Earth is evaluated over time, and every once in a while you will see new leap seconds be introduced that kind of make adjustments to UTC. Similarly, politics can change time zones as well as standard offsets. As far as number times this can happen, so far for leap seconds, there's been like 27 changes since the last one was in December of 2016. We're approximately 37 seconds off of atomic time at this point. Time zones themselves can change, so you may see around 10 changes a year as far as different countries changing their rules for what time zones they're going to, what the rules are. And then you've got standard offset, which is basically daylight savings time. So if you're in the United States, that'll change about twice a year. So at some point in time, daylight savings time will start to be honored. And then at some point in time, it will not be honored, which we will be on standard time. So that right there is kind of a quick history of some terminology when it comes to time zones. Now, the word time zone, I'll take a moment here to say that I feel like the word time zone is a very loaded term because it can mean a lot of different things in different contexts. The way I like to describe it is this idea where a time zone is kind of a region on the map that defines an area. And then you've got a rule set. So currently, the Eastern time zone is honoring the daylight savings time rules. Or currently, the Eastern time is honoring standard time rules. But if you're talking and looking up things, you'll see that word mean a lot of different things. It can mean both the concept of what rules are currently being applied, as well as just the name of that region on the map. So just keep that in mind. Time zone is a very loaded term. All right, so with all that said, let's talk a little bit about Elixir. So how does Elixir represent time? We'll start with the date and time structures, which in themselves, so date will, have values for year, month, and day. Time has values for hour, minute, second, and nanosecond. And you can create instances of those and use them to describe things. It can be helpful to describe things with just a date. So if you were to say, what is your birth date? For me, I would say 7/11/79. And there is no time. I mean, there is a time when I was born, but that's not generally what people ask for when they're asking for birth date. Similarly, it could be valuable to kind of keep track of a time to say that, coffee break time is at 3 p.m. every day, and that may be evaluated differently, but it can be stored as just a unique time. The next is actually a combination of the both. So we have nave date time, and this is basically just treating both of those values as one actual value unit. If you need to keep track of that now, know that nave date time does not have a time zone. So for that, we would actually create a date time structure, and that would introduce time zone, UTC offset, standard offset, and the zone abbreviation. And this is kind of where the time zone as a loaded term can kind of come into play. Now, a thing to remember is that all this was not present for Elixir 1.0. So don't be surprised to see some old holdovers from that era in the language and the libraries, and we'll talk a little bit about that when we get to Ecto. But this is kind of where it stands now. One other thing to kind of bring up here is even though datetime has a time zone, the Elixir runtime does not include a time zone database. So we'll kind of get into that in a second. So out of the box, when you're working with datetime, you will want to you'll be using UTC pretty much at all times. Okay, so all that said, this is what some code looks like. So if you wanted to generate a date or a time, or an AVE date time, or even a date time, you can use Sigils. Sigils are great in Elixir. They let you create textual representations of more complex object types, or value types, I should say. And so here we can use tilde-d or tilde-t to create a date or a time, or tilde-n to create an AVE date time, and tilde-u to create a date time. And notice the tilde-u is creating a GMT or UTC time, and you can tell that by the Z at the end. It's very important because, again, out of the box, you don't have a time zone database, so UTC is the only kind of option in town out of the box. So here's a kind of quick example of something that changed recently in Elixir 1.10. So historically, if you had a collection of dates or date times, and you asked the enum collection to sort them, you'd kind of have a problem because it would use it would not use the kind of the conceptual value that we're representing in the struct. It would use more of a memory address or something. And so the way historically you had to fix this was when you were using enum.sort and collection, you'd have to pass a custom, you'd have to pass a reference to the comparison operator that you should use, or a custom function. But in Elixir 1.10, they made improvements to sort. So now you actually have the option of saying if you want this sort to be ascending or descending. Helpful use of enum.sort, so you can basically say, I want to sort this collection and it's of these types, so you can say date, and because date implements a protocol, it'll know how to actually compare those dates. You can also do custom ascending and descending with that new option. So check out for that, but just keep in mind if you are using that to make sure your project does require Elixir 1.0. Okay, so I mentioned the time zone database before, so just to reiterate that time zone databases are not included by default, but they are easily accessible. A very popular one is called tzData, and you can find that on GitHub. And if you want to include it in your project, you can just add it to your dependency, something like this. And then when you configure Elixir, you can set its time zone database. That itself has a protocol. Time zone database will be set, and then you can start to use different time zone labels in the datetime function to create very specific date times that are of that specific time zone. And just so you're aware, when you do include tzData, it will run a process in the background to update itself. So over time, as you run your app, you will see it kind of fetching the new database rules. So I often see this kind of like if I haven't run an app in a while and I run my unit tests or I run clean or something, I'll see it pull down the fresh tzData. So just so you know, that will happen, and you'll see something on the console, the fact that it actually has been updated. In addition to tzData, there's actually a second alternative you can use for a time zone database, and this is simply called TZ. And from reading on the Elixir forum, the basic idea behind this new offering is to help fix some bugs. So, as you may discover over time, the time rules have changed over, as time's gone on. And so if you're using Elixir to kind of process older dates, let's say you're building something for a history museum and it's got lots of old reference dates in there, and for some reason it needs to actually generate durations or something between those dates, it can be helpful the TZ database is kind of influence how that is figured out. So TZ has been fixing some bugs, and we'll see in time if it becomes the more preferred one. Right now, TZ data, I would say, is more popular, but you can keep an eye on this if you're interested as well. All right, so that covers Elixir as a language. Let's talk a little bit now about Postgres and Ecto. So the general guidance you'll get from people is to store everything as UTC, and that is extremely very helpful guidance. It's definitely a good first step. The problem that I have with the kind of current out-of-the-box solution is that Ecto, when you save Ecto schemes and datasets to Postgres, there's an assumption of UTC, but there's no kind of formal contract. So if you actually look at the data, you'll find that there is no time zone info actually stored in the database. And if you're just living in Elixir and like that's the only way you'll ever access this data, that's not really a problem. The issue I foresee is that you have an app and it's generating data over time, and then at some point, some marketing person or somebody who wants to do statistics, they, instead of going through Elixir, they go right to the SQL and they start doing date time function math, and at that point, Postgres is going to use the time zone of the client connected to the database. So let's say your marketing person lives in San Francisco. All of a sudden, all those timestamps are going to be interpreted as San Francisco time, and that may lead to very subtle, statistic bugs. And so you'll run the statistics, and you'll see things are just off a little bit, and you really have no idea why. And so my solution is basically to store that data in the database. So we're going to walk through an example here. So let's say I have an Ecto schema for users, and I've created one for users, and they've got a name, which is string, obviously, birth date. Birthday is date, nap is time, born at nave is nave date time, born at UTC is UTC date time. And so that's our schema, and then our Postgres definition matches up pretty much verbatim, and then we've got timestamps, which we're just going to use the default out-of-the-box timestamps function to generate those rows. So if we run that migration and we kind of peek at our database tables, we'll see that we get pretty reasonable stuff for name and birth date in NAP. Born at nave, without time zone, that makes sense. But if you look at born at UTC, you'll see it is a timestamp without time zone. You'll also see that inserted at and updated at are both as well without time zone. Now, the way you can fix this, if this is a concern of yours, is basically inside of your schema, you continue to use UTC datetime for your field type. And then for timestamps, you are a little bit more explicit and say that you want the UTC datetime to make sure that that is the type you want. And then for the migration file, you, instead of UTC datetime, you will use timestamp Z. And what that'll do is that'll guarantee that the columns that I create actually contain the time zone. So we run that migration, and now we see born at, inserted at, and updated at are all timestamp with time zone, kind of fixing our fear of subtle bugs. Okay, so now we'll move on to talking a little bit about HTML and web apps and Phoenix. So here's our kind of scenario. We've got the user using a browser and user kind of thinking in wall time. And then we've got our web app in Phoenix talking to Ecto, which eventually will talk to Postgres. And, why is this a challenge? So this is a challenge for a couple of reasons. Now, talking about web apps in general, there's kind of two styles for building a web app these days. One is the more traditional request response type, which is what you'll get kind of out of a, out of the box Phoenix experience, where somebody asks for a page is delivered, user fills out a form, they submit the form back to the server. And then you've got the more front-end JavaScript apps, so things like React or Vue, or even Live View if you're using Phoenix Live View in a bigger way on the front end. And the problem with request response is that time zones are not part of the HTTP protocol. So they're not sent in the header. There's like, so when the header comes in for the request, there's nothing saying what time zone the user's in. Now, you could try to use the IP of the user to kind of figure out where they are, but that's definitely something that can fail, and it does require a little bit of overhead for the request. The other thing you can do is actually use JavaScript to access the time zone. So through JavaScript, you can actually ask JavaScript for the time zone, and JavaScript will ask the browser. The browser will ask the system. And so you can get access to the time zone, but you have to, unfortunately, use JavaScript. All right, so let's say we're going to use JavaScript to figure out the time zone. How do we want to use that to figure out, to solve our problems? So one way is totally on the front end to use JavaScript. And if you want to present a time to the user, you can have the server serve a static page with UTC, and then using the time tags of HTML, you define where that is, and then you use JavaScript to kind of discover the time zone, and then rewrite the DOM, specifically those time labels, in the native time zone of the user. I know there is actually a plugin for Rails that does this. I'm not aware of any for Elixir that do it. But it does have a bit of overhead in that it's going to run on every page. It makes sure normally a static site requires JavaScript, and you may not like that. The other way kind of you can handle it, depending on the nature of your app, is to have the time zone discovered by JavaScript and then reported to the server so you can use it for future pages. This does kind of have the unfortunate side effect is that the initial page that the user loads will not have the user's time zone. But again, depending on the nature of your app, they may or may not be an issue. Another kind of third way is to kind of ask the user. You see this in forum software a lot, where the user's going to register for the forum, and as part of that forum, they say, I'm in Eastern time, or I'm in, Pacific time. And then the forum from that point on will just transform all the date times on the server to the user's time through that. But it does have some side effects, like once you ask the user what time zone they're in, and then it's kind of static. And so, like, if they're traveling, and let's say they live in New York, but they're going to California for the week, all of a sudden they're typing in things in New York time, but it doesn't make sense because they're in California. And so that has its pitfalls. So for myself, I'm actually working on an Elixir app right now that is kind of like a meetup.com competitor where people create group pages, a group, and then they create members for the group, and they create events in that group, create an event calendar. And so the way I've solved this for my end is that when a user creates a group, we try to detect the time zone through JavaScript. And then that is set up as like the group time zone, because typically these groups are more localized. So like you have like a Philly technical group doing something. And then when we're serving pages, we use JavaScript to, fetch and report to the time zone to the server. And then we store that in the user session. So this does require cookies, which, cookies are not they're a bit of a privacy discussion, but most people accept cookies. And so that's not too big of an issue. And then what happens on page load, and we want to display some date times for, let's say, the event calendar, we use kind of a fallback system where we try to get the user's time zone, and then if that fails, we get the group time zone, and then if that fails, which it really shouldn't, we use UTC as kind of an immediate fallback. And the basic idea is that, we want to make sure if they have JavaScript turned off for some reason, that the site still works. Some sites don't have this restriction, but this is one we're shooting for, so that's kind of into our design specification. So that talks a little bit about presenting time in a web app. Let's talk a little bit about accepting time. So let's say you've got forms for people to create things, and for my app specifically, people create events. And so I have this form right here, a new event form. And I ask for time as components. And so I ask for a starts at date in the form of an input date picker. And I kind of lean on the browser to kind of show this date picker. This is more HTML5-ish date picker types that almost all browsers support. The only known browser that I'm aware of, like modern browser, is Safari on the desktop. For Macintosh users, they sadly do not support this. They do on mobile, but not desktop Safari. And then, so they pick a date, they pick a time, and I've chosen to kind of present that as a picker with predefined times in 15-minute increments that should match most users' needs. And then I have a duration, which is similar, has fixed duration times from anywhere from 15 minutes to 3 hours. So what happens is when they hit submit on this form, I need to interpret this time and figure out the time zone for this date time that they've chosen. So they're supplying me with a month, month, day, and year, and then they're supplying me with 1 p.m., and then they're supplying me with duration. And then through that, I need to figure out the start time, the end time, and then what the time zones are. And the key kind of thing to remember at this point is that the time zone rules are very date relative. So let's talk about an example here. So let's say the user is using this web form and it's February 12th, 2020. It's 8:30 p.m. They're creating a new event for this date time. When they send it to the server, I need to understand that the user is in Eastern time and they're trying to figure out the time zone rules for this moment in time. And that actually, turns into Eastern Standard Time. But if they were to, give me July 11th, 2020, then that would evaluate into Eastern Daylight Time. So you've got to do this, kind of have to do multiple conversions to kind of figure out the ultimate storage type. And the way I kind of do this here is I take all the form elements and then I combine them into an Elixir naive date time. So that's a date time that has no time zone. Then I figure out the resolved time zone name, which again is based off of that list, either the user's time zone, the group time zone, or UTC as a fallback. And then what I'll do is I will convert that naive date time into the custom into the user's, time zone, so the time zone that was relative to the form. And then once I have that, that's a fully described date time now. Then I convert that to ETC, which is the actual date time that I store. And then that'll be ready, as a kind of a unified storage system for all the date times. And so you have to do this on storage and retrieval. And I wouldn't say that this code right here is necessarily the most cleanest way to do it, but it's kind of an example. I would imagine over time, as you're building your app out, you would build macros to kind of help out with this. But this kind of shows you, how the basic ideas work. So that was my talk on time zones. Hope you guys had a good time. I want to give a huge shout out to Lau from ElixirConf 2019, who did a talk on date, time, and time zones. I was totally inspired by a lot of his visuals and reused them in the early part of this keynote, so keep that in mind. And if you yourself are looking to get started with Elixir or looking for a refresher on date and time, you can check out Elixir School. They've got a great tutorial system there. Then I got some links here to some of the GitHub repos that we talked about. I want to thank you for watching. Before we go, I also want to just give a quick plug to my own website, mikeszornik.com. I am available as a contractor or consultant. I do a lot of Elixir stuff, including Phoenix, Absinthe, development, and I also have a large history of doing Mac and Macintosh and iOS development as well. So if you looking for any projects, definitely let me know. And if you have any questions about Elixir, definitely let me know. I'm hoping to do some more videos like this in the future. Other than that, keep safe, keep busy, and thanks for watching.